Hey everyone, welcome back to the channel. Imagine you are building a Django application in that a new user signs up, and along with creating the user, you also need to create a profile, send a welcome email, generate default settings, create a audit log, and maybe even notify the admin. So you write all of this inside your registration view. Everything works perfectly until one day an admin creates a user from the Django admin panel. Or maybe a user is created through a REST API or even a management command. Suddenly, no profile is created, no welcome email is sent, no audit log is generated. Now you are stuck copying the same code into multiple places and your application becomes harder to maintain. So how do professional Django applications solve this problem? The answer is Django Signals. In this video, we are not gonna just learn how to write signal, we are gonna understand why they exist, how they work internally, and why you should and shouldn't use them. By the end of this tutorial, you will be able to confidently use built-in signals like post save, pre-save, post delete, etc. in your own Django projects. So without wasting any more time, let's jump right in and first understand what Django signals actually are. So have you ever written code like this? Like user creates, profile is created, send welcome email function, and create notification function and create activity log. So when a user is created, all this should be running. So looks fine, right? But what happens when a user is created from somewhere else? Maybe from Django admin, maybe from a management command, maybe from an API. Suddenly, no profile is created, no email sent, no notification is created. Now you start copying the same code everywhere. Exactly the problem Django Signal solves. So now whenever a user is created, I want all this function to be run. Create profile, send email, create notification, create log. The problem. So let's imagine we are building a social media application and every time a user signs up, we want to do 5 different things. That is the same things I'm telling. Create profile, send email, generate default settings, create a notification and create a audit log. So most of the time we will write all this inside the registration view. So it will look like this. In the registration view, we'll write all these things, user, profile, sent, all these things we will write in that. This works perfectly until someone creates a user from another place. Let's say from admin panel, they will create a user. So now there is no profile created, there is no email sent, there is no default settings created, no notification. The same may happen while using the REST API also. Here nothing happens again. Why? Because all our logics only exist within our one view. Here the real problem is duplicate business logics. So whenever you create a user, you must always also remember to write profile.object.create. This profile.object.create we have to write every time. Now you will be writing this again. Let's say for admin panel you have to write, for management command you have to write, and for API again you have to write. So eventually your project will keep on looking like this. So first you will write in the registration view and you will create that in the API create profile in admin, create profile in management command, and then create profile. That's not only repetitive, that's also easy to forget. Let's say you made some changes to this create profile or some other functions related to that, but you forgot to change that in any one of them. So your code will almost break. So now what exactly is a signal in Django? Let's forget programming for a minute. Imagine you are at a home. Someone presses your doorbell. What happens? The bell rings. Does the bell know what's going on? Does the bell know who is going to answer? No. Maybe your father comes to open the door, or your mother checks the camera. Maybe your dog starts barking. Maybe nobody answers. The bell doesn't care. Its only job is to announce someone is at the door. That is what exactly the Django signal is. It doesn't perform action itself. It simply announces something just happened. Then every function that is listening to it can react. How it works with Django means, so whenever a user is saved, a signal is triggered, it just informs. And then the functions which we have created for creating the profile, sending email, creating notification, and create audit log is triggered. Now, if you notice something interesting, here the user module doesn't know about emails at all. It doesn't know about notification. It doesn't know about logs. It will just simply says, hey, I was saved. Anyone interested can React. Every application has events. For example, if you know about JavaScript, there is an event called button.addListener click function. So when someone clicks a button, this button doesn't know what your function does. It just simply announces someone clicked me. Django works exactly the same way. Whenever something important happens, Django fires an event called a signal. For example, when a model is saved, it will trigger event called post save, and before saving it will trigger event called pre-save, and when an object is deleted it will trigger a function called trigger an event called post delete. These are simple notifications. Now these are the some of the few signals present in the Django. So that is, one is pre-save, before saving it runs; post save, that is after saving; pre-delete, before deleting; post delete, after deleting; and m2m changed, many to many relationship changes. Don't worry if this name seems confusing right now. By the end of this session, by the end of this tutorial, you will know exactly how each one works. So again, I'm telling, signal is not a function, it just sends a notification. It's just a reminder, that's it. You may think whenever a signal is called, it will call some functions. No, it doesn't do that one. Instead, it just tells something happened and Django announces it, and anyone listening it to it reacts. Now that we understand the concept behind Django signal, we know they are not some kind of magic. They are simply Django's way of saying, hey, something important just happened. We also saw the problem they solved and why writing the same logic in multiple places isn't a good approach as your project grows. But understanding theory is only the first step. In the next session, we are going to create a Django project from scratch and implement our very first post-save signal. We will see exactly how Django detects that a model has been changed, how a receiver listens for the event, and how we can automatically perform actions like creating a user profile without writing duplicate code. Now that we understand what Django signals are and why they exist, it's time to stop talking about theory and actually build one. In this section, we will create a brand new Django project from scratch and implement our very first signal using Django's built-in post-save signal. Our goal is very simple. Whenever a new user is created, Django should automatically create a profile from that user. The important thing here is that we are not going to manually call a function like create profile. Instead, we are going to let Django detect that a new user has been saved and automatically perform the action for us. By the end of this section, you will understand how to create signals, how post-save works, what the sender parameter means, what instance is, what the created variable does, why apps.py is required, and how Django knows our signal exists. So let's jump into VS Code and start building. Here, I have just initiated a Python project and added the Django here. Now I'm gonna create one project. Inside the project, we are creating a new application called accounts. We will keep everything related to users and profile inside this app. First I'm gonna register this app. Now if I open my app structure, as you can see, there is no signals.py. We will create that ourselves. Now let's create a model here. So first I'll go for the model. So here, instead of creating our own user model, we will use the Django's built-in user model. This is much more realistic because almost every Django application starts with user authentication. Now I'm going to create a model called profile. And here I'm going to use the two fields called user bio and one called created at. So here I have written models.one-to-one field. So a profile belongs to exactly one user and every user has exactly one profile. This creates a one-to-one relationship. So here it will create user one user per one profile, not like one user can have many profiles. Next here, I have added on delete models.cascade. This means if a user is deleted, delete the profiles too. No, so that no orphan records remain. Next, bio. Bio is just an example field. Since it's gonna be blank as soon as a user is created, so I'm giving it as blank. And next is created. Let me go for created at. No sense. It will automatically stores when the profile was created. Now I'm gonna run the migration command. So now Django has converted our Python model into SQL and created the database table for us. Now I'm gonna register this profile in the Django admin panel. For that one, I will go for the admin, and here this allows us to see the profiles inside the Django admin. Now let me create a super user so I can access the Django admin page. Here for everything I'm using UV. You can use the pip also. Okay, the import is a mistake here. Now let me run the project. Now let me go for the admin panel and login. As you can see, profile is registered here, and there is 0 profiles, and users are there, which is created by the supervisor command. As you can see, users are there, but creating a user automatically does not create a profile yet. Now let's create our first signal. So for that one, Django doesn't create a file called signals.py automatically, but we have to create it ourselves. Now in the accounts, I have to create a file called signals.py file. Django doesn't create this file automatically since it's simply a convention. Whenever we want to use signals, we will usually create them inside the signals.py. Now let me import something and I will explain what each and everything is done. So first is import the signal. So first is post save. In the before video, I have explained about a doorbell example. Whenever a module is successfully saved, Django rings the doorbell, and that doorbell is called post save, meaning object saved and post save, and everyone listens gets a notification. Everyone listening to that post save will get a notified. And receiver, this is a decorator. Its only job is telling Django this function wants to listen for a signal. Without this decorator, your function is just another function. Django ignores it. So here we have imported the user. We are saying whenever user changes, we want to do something, and profile, we will create it automatically. Now our first signal. So this is the most important part of today's video. So let's understand every line. First is this receiver decorator. Now how this receiver works is, receiver will first listens the post save, and after saving it will send the users. Only when the user is saved, this will trigger. Not a profile is created, not when product is created, or not an employee, only user. Whenever a user is created, then only this will listen. So whenever a user is saved, it will fire a signal, but when a product is saved, it will do nothing. Next is create profile function. This name doesn't matter. You can call it hello also, it will work, but for name convenience and remembering the things, make it easy, we will give it as create profile. The decorator is what is matters. Next is sender. So sender tells us who fired the signal. Here it will always be user, since we have already specified sender is equal to user. Instance, this is one of the extremely important. Instance means the object that was just saved. Example, if someone creates a user with username Amruth, instance becomes user is equals to Amruth. So instance.username will always be Amruth. Now if instance.email returns always the user's email. Think of instance as the newly saved row. Now this is where many beginners get confused. Let's say something is created, the signal will be called and it will become true. Now if some user is instead of creating, we will edit some user's name or email ID, it will not become true. Here we are using created. Here what does this means? Suppose a user is created, this will become true. Let's say if a user, let's say I change the username to something else, then it will become false and it will not call this at all, because we didn't create a new user, we only updated one. That's why we write created if created condition. Otherwise every update would create another profile. Let's say I updated a name, it will create a new profile. I will update a email ID, it will create a new profile. I will update a password, it will create a new profile. So imagine changing your email, suddenly another profile, change password, another profile, update first name, another profile. That would be a disaster. Finally, we are creating a profile. Remember the instance we talked about, it is the user. We are simply creating a profile that is connected to the user. That's it. No duplicate code, no manual functions, everything happens automatically. Now if I save this and I will just stop the server and start it again just in case. Now I will go for the Django users and I will create a new user here. For now I will just disable the password. See, now I've created a new user, but there is no profiles here. So nothing happened. See, many beginners stop here. They think signal don't work. Actually, Django doesn't even know this file exists. Python only runs files that are imported. Right now, nothing imports signals.py. So Django never executes this file. So for it to work, we need to import that inside the apps.py. Here, we need to import that. So here we want to import the accounts.signal here. So here ready means run only once. When Django starts inside the ready, we import the signals. The moment Python imports this file, our decorator executes. The signal gets registered. Now Django knows whenever a user is saved and runs the create profile. Now if I go for the visualization of the thing means, so here what that means, Django starts, it will run ready and it will import the signals.py and register the receiver and done. So now for testing, let me rerun the project again. Now if I go here and go for the users, let me create a new user. Now if I go, as you can see, profile exists now. Notice something, we never wrote create profile. We never called the function ourselves. The only thing we did was create a user. Everything else happened automatically. This is the power of Django signals. Now let me create a new super user called admin1 and password I will give something. Now if I refresh the project, okay, I stopped running it. See, as you can see, I didn't specify it in the management command also. I didn't specify anywhere, but it's working. Wherever I create a new user, it's gonna create one profile for me automatically now. So how does this works means, First, in admin panel, a user is created, user.save is called, and it goes for the database, and post save is called, and receiver is called, and it will create the create profile, and profile is saved. How it works means, say whenever a user is saved, Django announces, hey everyone, a user was just saved. Our receiver is listening here. So it reacts, creates the profile, and done. Now here a common beginner mistake is forgetting the apps.py file. That is what we did at the last. We have to import this. Without this, the Django will not know if the signal exists or not. Next is forgetting the sender. Sender also we need to pass it here. We have to send something to the sender. Next is forgetting if created. This is one of the things. And creating another user inside the signal, causing recursion and putting too much business logics inside the signal. And best practices are always keep the signal small. One responsibility, use them for side effects. Name receivers clearly, always register them. As I said, we can name it as something, hello, ABC 123, anything you can name it, but it will work. But it will be confusing as you go, as your project builds into a bigger project. So today we built our very first Django signal. We learned what the post save signal is, how it detects when a model has been saved, and how Django automatically executes our receiver without us ever calling the function manually. We also explored what the sender, instance, and create parameters actually mean, why the ready method inside apps.py is essential, and how the entire flow works behind the scenes. At this point, you should have a solid understanding of the most commonly used signals in Django and be comfortable using it in your own projects. In the next session, we are going to look at another extremely useful signal called pre-save. Unlike post-save, which runs after an object is stored in the database, pre-saves gives us a chance to modify data before it is saved. We'll use it to automatically format data and explore how it can help enforce consistency across your application. So let's continue and see how pre-save works. In the previous section, we learned about post-save signal and saw how Django automatically creates a profile whenever a new user was created. But Django doesn't only notify us after saving an object. Sometimes we want to modify data before it reaches the database. Sometimes we want to perform an action after an object has been deleted. And sometimes we want to know when a many-to-many relationship changes. That's exactly what Django's other built-in signals allows us to do. In this section, we will explore three important signals: pre-save, post-delete, other commonly used built-in signals. By the end of this section, you will know exactly when each signal should be used and what problem it solves. Before writing any code, let's understand what actually happens when Django saves an object. Suppose we will create a user using the use.save method. Many beginners think Django immediately stores the data in the database. Actually, several things happens in order. So first, create user object whenever we call it. So here, the object is first created in the memory. Before Django writes anything to the database, it first fires the pre-save signal. This gives us chance to modify or validate data. After the object has been successfully saved, Django fires post save. Think of it like sending a package. So as I shown here, the quality check will happen before shipping. The delivery confirms after the shipping. The same idea applies for the pre-save and post-save. So what is pre-save? Let's imagine users create a username like Amruth, or sometimes they will enter like this, or sometimes they will enter the capital letter itself, or sometimes they will mix it both or something when typing. So your application wants every user to save in uppercase. Without pre-save, you have to remember to do this everywhere. Like whenever you save, you have to type username is equal to user dot upper, and then you have to save the user like this. So every management command, that's a duplicate logic. So instead we can use the pre-save. So now let's go into the code. So I will go for the signal here. Now along with the post save, let me import the pre-save also. So here, just like post save runs after saving, pre-save runs before saving. Nothing has been returned to the database yet. Now let us create a receiver here. Instead of the user, I'm going to pass the profile here, since we want a change in the profile itself. Now I'm going to define something called uppercase. So here, instead of changing the username only, I will change the bio for here. And here also, since bio is optional, first I have to make sure the bio is entered. So first let's understand every line. So here, the receiver, we're telling Django, whenever a profile is about to be saved, run this function first. Notice we have listening to profile here instead of user. Remember from the part 2, instant is the object currently being saved. If the profile contains something like I love Django in the bio, instance become the profile itself. We simply modify it. Instant.bio is equals to instant.bio.upper before Django writes anything. Now for testing, I will go for the admin panel. Let me save this first, and program is running. So I will go for the admin panel, and here I will go for a profile for admin 1, and here I will type something like I love Django Signals. Now let me save this, and if I go here, so here the signals are not the function is not running because here I'm using post save instead of pre save. Now let it run, and now if I save and continue editing, as you can see, it has converted to capital. So did we manually call this function? No. Did we edit the admin? No. Did we change any views? No. So Django automatically executed the signal before saving. That's the beauty of pre-save. So if we go for a comparisons of pre-save and post-save, pre-save will modify the data and then send the data to database, and post-save, first it goes to the database and then performs an actions. So we will use the pre-save whenever a data needs to change before storing, and post-save when something should happen after the storage. Now what is post delete? Now let's imagine another situation. Suppose every user uploads a profile picture. So each user will have profile.jpg. Later the user gets deleted. The database row disappears, but the image still exists on the disk. Now your server starts filling up with unused files. This is where post delete becomes useful. So in this case, I'm not gonna change any module, but I will show how it works here. Now I will just import the post delete also. Instead of deleting a picture, I'm gonna show some. So here, whenever a profile is deleted, Django automatically calls this function. Notice the object has already been deleted from the database, but still Django passes us the instance, meaning we still have access to its values like this instant.user.username, user instance.bio or instant.created. Everything is still available inside a signal. So let me try it out. So let me open the terminal, it's running. Now if I go to the admin panel and let me delete this profile. So let me check, I'm passing the profile. Yeah. So I'll pass this admin and let me delete it. As we can see, profile for the user admin 1 has been deleted. Now if I go for the users and go for the admin 1 and let me save this. As you can see, our post save will only work if it is creating for the first time, only if created. We are not giving a some condition like if created or not present, then do the things. So for that one also you can use it. So instead of printing, real application often do something like, let me show you. They will either delete uploaded image or delete cached files, write audit logs, notify administration and clear Redis cache. So this signal becomes a cleanup mechanism. Now that we have seen pre-save, post-save and post-delete, let's quickly look at some other useful built-in signals. So first is pre-init. So runs before a model object is created, and post-init runs immediately after the object has been initialized. So also rarely used. We know the pre-save and post-save useful when you need information before the removal. Post-deletes, as we can saw earlier, it runs after the deletion, great for cleanup tasks. And M2M changes. This signal is extremely useful. Suppose a student can join many courses. One course can contain many students. That's a many-to-many relationship. Whenever someone adds or removes a course, Django fires the M2M changed. You can then update the counts, send notification and log activities. Let's say it's like this. So how this works means, when we create a object, first it is pre-init will run, and afterwards post-init will run, then pre-save and the database is saved the data, post-save, pre-delete, when the delete is done, post-delete. So common mistakes are, don't use pre-save to send emails. If the save fails, the email was already sent. Use post-save instead. Don't use post-delete. To access related objects that no longer exist in the database, store what you need before deletion if necessary. Don't modify objects inside post-save without understanding the recursion. Calling save inside post-save can trigger the same signal again. So best practice are pre-save for validation and formatting, post-save for notification and side effects, post-delete for cleanup. We should always keep the receivers short, move the heavy tasks to celery if needed. So in this section, we explored how Django provides multiple lifecycle signals for different stages of an object's life. We learned that pre-save allows us to modify data before it reaches the database, making it ideal for formatting and validation. We saw how post-delete helps clean up resources after an object has been removed, and also took a tour of several other built-in signals that Django provides. Once you understand the purpose of each signal, choosing the right one becomes much easier. So far, we have only used signals that Django provides out of the box. But what if your application needs to react to an event that Django doesn't know about? For example, if a payment succeeds, a order is shipped, or a report is generated, can we create our own signal? The answer is yes. In the next session, we will build our own custom Django signal, learn how to trigger it manually, and then finish by discussing the biggest mistake developers make when using signals and when you should avoid them altogether. So far, we have learned about Django's built-in signals. We used post-save to automatically create a profile. We used pre-save to modify data before it reaches the database. We also looked at post-delete for cleanup tasks. But here's an interesting question. What if Django doesn't provide the event you are looking for? For example, a payment was successful, a report was generated, a user completed onboarding, an invoice was approved. None of these are built into Django. So are we stuck? Not at all. Django also allows us to create our own custom signals. In this section, we will learn how custom signals work. And then we will finish with something that's arguably even more important, when you should avoid using signals altogether. So let's dive in. Before we create a custom signal, let's go back to our doorbell analog from part 1. Imagine your house comes with a built-in doorbell. Whenever someone presses it, everyone inside knows that someone has arrived. That's similar to Django's built-in signals. But imagine you also installed a smart security system. Whenever motion is detected, it sends a notification. That notification wasn't built into the house. you added it yourself. That's exactly what a custom signal is. You are defining your own event. So building signals are like, so when user saved is an event, when it ran, post save signal will run and receivers will receive it. But custom signals are what we create. We will create a payment successful, and payment successful signal will run and receivers will receive it. So let's dive into the code. Here, instead of doing everything here, we will create our own custom signals file. So we are separating our custom signals from Django's building ones. This keeps the project organized. First, we are going to import signal from Django.dispatch. So let's understand this line now. So we are creating a new signal object. Nothing magical happened here yet. We are only creating an event. Think of it as creating a new notification channel. Right now, nobody is listening to it. Nobody is sending it. And it simply exists here. So first we have to register that. So first in the signals.py, I'm gonna import it. Now let's create a receiver. Unlike post save, this signal doesn't automatically receive a instance or a created. Why? Because we created this signal, we decide what information gets sent. Notice our function has amount and user passed inside it. Those values will come from whoever sends the signal. Now imagine the payment was successful. This is where you use payment successful.send. In the place where the payment actually succeeds, such as a view, payment callback, server function, or webhook handler. So for example, let me call that inside my view. Here, this line triggers the signal. Think of it as ringing the bell. The moment Django executes payment.successful.send off, every listener listening will execute automatically. For testing, I will add this directly to the URL TPI. So after adding this one, I need a HTML template. So let me create this one here inside the accounts. So inside the template, I will just call the amount directly. I'm not going to do stylings and everything. So here, if I run this server and if let me refresh it and let me go for the site, since I've added it as the first one, 100 is coming. See, as soon as that is called, this view is called, the payment successful.send is called. Now I'm receiving the print statement calling payment received from the admin, that is the logged in user. I was logged in as admin here, and 100 is what I am passed it here for an example only. So how this works is, as soon as the payment is completed, the payment underscore successful dot send is called, and that is sends a signal. Afterwards, the receiver will receive this signal and it will print the message for us, or if in case we want to send an email, update the wallet, or generate an invoice, everything will be run through this receiver. So this is where custom signals become powerful. Suppose you are building an e-commerce website. Customer completes a payment. Instead of writing everything in a view like payment, create the invoice, update the wallet, send email, notify admin, create audit log and reward points. All these things in one view. You can simply do it like, as soon as the payment is successful, send a signal. The signal is received by invoice receiver, email receiver, wallet receiver, reward receiver, and analytics receivers. So each features becomes independent. Your code becomes much easier. Your code becomes much cleaner. But now comes the most important lesson of this entire video. Should we use signals for everything? Absolutely not. Many developers discover signals, then suddenly everything becomes signal. Login, signal. Logout, signal. Payment, signal. Order, signal. Tax, discount, everything is signal. Soon nobody understands what the application is doing, because important business logic is happening silently in the background. So it's like this view, and everything is going through signals only. Another signal, and nobody knows what happened. So what are signals good for? Signals are excellent for logging, notifications, emails, analytics, cache clearing, search index updating, profile creation, and cleanup. Notice something, these are all side effects, meaning they happen because something else happened. Never put your application's main business logic inside signals. For example, don't do like, if a user pays, signal will run. It shouldn't update the bank balance, create the invoice, ship product, reduce inventory, notification, notify warehouse. Why? Because these are critical operations. Imagine another developer reading your payment view. They will only see payment is processed. They won't realize 5 other things happening automatically. That's dangerous. So you should remember one rule. So business logic should always keep as explicitly. Side effects should be kept in the signals. If your application cannot function with that code, don't hide it inside the signals. If it simply react to an event, signals are a good choice. So the difference between signal and function is, function are direct. Function is like you call it, it runs immediately. But signals are event driven. Signals will run only if something happens, some event happens, it will react to a receiver. Some of the common mistakes beginner can do is forgetting the apps.py. So as soon as you create a signals.py, you should register that in apps.py. Next is, in case of creating a profile, creating some view which is one-to-one or something, you should always be careful to write this if created. Otherwise, multiple profiles get created. Next is calling. You should never call instead dot save, because inside the post save, this triggers post save again, which calls the save again, and infinite recursions will happen. Like, what means? So once you save something, the signal will run again, it will call the save function, and again signal will run. It's like infinite loop will be keep on happening. So always be careful when saving inside signal. And mistake number 4 is doing heavy work inside the signals, like resizing the image, generating PDF, uploading files, AI processing, video encoding. Don't do this. Instead, queue background jobs using Celery or another task queue. Signals should finish quickly. So some of the best practices are, you should always keep the signals short. You should have only one responsibility. You should use the descriptive name, like here I used uppercase bio and profile delete, because profile deleted, because these things will do according to what the name is suggesting. If you keep this as home or delete, it doesn't make sense, and you will only get confused in the next session if this is a lengthy code. And you should always register signals in the ready, that is this one, and avoid recursion save. That is what I told about instance.saveoff. And you should test the signals and use logging instead of print in production. Keep business logic outside signals. So let's quickly recap everything we have learned. A signal is simply a notification. Django announces that something happened. Receiver listens for that event and react automatically. We explored post save, pre-save, post delete. We created our own custom signal. We learned how to register receiver. We understood sender, instance, and created. Most importantly, we learned that signals are excellent for side effects, but should not replace clear business logic. Once you understand that distinction, You will know exactly when signals make your code cleaner and when they make it harder to maintain. So congratulations, you just learned one of Django's most powerful and most misunderstood features. If you have been writing duplicate codes across multiple views, APIs or management command, I hope this video showed you how Signal can help you write cleaner and more maintainable application. At the same time, remember that just because signals are powerful doesn't mean they should be used everywhere. Choosing the right place for them is what separates a beginner from an experienced Django developer. If you found this tutorial helpful, consider giving it a like and sharing it with other Django developers who are learning the framework. If you have any questions, suggestions, or topics you would like me to cover next, let me know in the comment below. I read every single one. And if you don't want to miss upcoming Django tutorials, project walkthroughs, and development tips, make sure to subscribe to Code with Amruth and turn on notification. Thank you for watching, and I will see you in the next video. Happy coding.